Solve the previous problem if the coefficient of restitution, that is E, use theta equals to 45 degrees, E equals to 3/4 and height equals to 5 meters. Now we are going to solve this problem as we did the last one, but the additional part in this question is that the concept of collision is also there. So we'll be doing the same thing, finding out the time and finding the displacement s then along the incline. But the thing is that the initial velocity will change along the plane because the collision is not perfectly elastic. Now let us understand this problem. We are having the inclined plane of angle theta where it is 45 degrees. The ball is falling like this at an angle of theta that is 45 degrees. And we have been given that it moves, that means it is actually bounced back by this incline at an angle alpha because the coefficient of restitution is basically E here. So now let us take that the velocity with which it falls on the incline is V. So we can say that V equals to under root 2gh. H is 5 meters, so this comes out to be 10 meter per second. Now friends, we are having the coefficient of restitution equals to 3/4. This velocity of the ball is in two directions. One is along the plane and one is perpendicular. And we know that the component along the plane is not going to change. That is going to remain the same because separation and coming together, that is the approach, are along that is perpendicular to the inclined plane. That velocity is responsible for that. So parallel components will be same. So I can write down V sine theta equals to V dash sine alpha, where V dash is the velocity after the collision. So writing the value of V is 10 and sine theta is 1/√2. So we get here 5√2 equals to V dash sine alpha. Let us mark it as equation number 1. Now friends, let us apply the value, the equation of coefficient of restitution in the direction perpendicular to the plane. Now E equals to velocity of separation upon velocity of approach. Separation is due to V dash, so it will be V dash cos alpha upon approach velocity, which will be V cos theta. Why? Because this angle will be theta and it will be approaching like this with V cos theta. V cos theta is again the same, that is V10 cos theta 1/√2, so that is 5√2 and this is 3/4. So I can write it as 3/4 equals to V dash cos alpha upon 5√2, giving us V dash cos alpha to be 15√2/4. Let us mark it as equation number 2, and dividing the equation 1 by 2 we get the value of tan alpha, that comes out to be 4/3. Now we have found out the angle. Now we can work to get the velocity V dash. So V dash into sine alpha, which is 4/5, equals to 5√2 from equation number 1. So we get V dash to be 25√2/4. So this was actually the role of coefficient of restitution to give us the value of V dash. In the previous problem it was equal to V because it was elastic collision, but it is not elastic. It has some value of E, so we did this part and we got the V dash. Now the procedure is same. We will be finding the time of flight and then the distance covered. So let us employ the first equation of motion to get the time. It will be a projectile motion, right? So let us find the time it takes to reach the highest position. So that is in vertical direction, final velocity will be 0. Initial will be V dash cos alpha minus acceleration is g cos theta, we know, along the perpendicular, this one, because this is g and this is theta, so it will be g cos theta into t. This gives us the time to be, putting the value of v dash from here, cos alpha, g and cos theta, we get the time to be 3/4. But the time of flight is double of this, because it is the time taken by the ball to reach the highest position, that is here, but it will be coming down. So the time of flight is basically double of this, that is 6/4. So this is 3/2, that comes out the total time of flight. Now we need to find the distance traveled along the inclined plane. So let us employ the second equation of motion after that, in which we know that S is equals to ut plus half at square. Now we need to find the S. U is, since we are employing it along the plane, which is v dash sine alpha, and the time is 3/2, because the time of flight, plus half acceleration, which is g sine theta, right, and t square, which comes out to be 9/4. Putting the values of v dash sine alpha, g and sine theta, we get this value of S to be 105√2/88. That is approximately 18.5 meters. So this is the answer for this problem.